Hello friends, welcome to Notebook. Have you ever tried fixing small electrical devices such as radios or transistors? Have you ever opened up a device and then had a tough time putting it back together? This video will be very useful to understand how circuits work and not end up with an open device and no clue what to do. You're actually using some complicated circuits right now. As you watch this video, your device is drawing energy from a source and you are able to view this video because of a completely functional circuit. Now, what are circuits? Simple circuits are a basic combination of a power source, switches, and a bulb or resistor connected via wires. So when you switch on the light of your room, the bulb lights up only because electric current successfully flows through the circuit that connects the bulb, the source of the electric current, and the switch. Circuits can become very complicated, but for now, we will just learn about a simple circuit diagram. This shows a battery source, a switch, and a bulb. The corresponding circuit diagram depicts the same things but in symbols. This is to simplify circuit diagrams that you may be asked to draw in your exams. So now, you will be able to draw a circuit diagram with symbols, right? Make sure you remember all the components. One important component of a circuit are the switches. For example, you see that there are specific symbols for switches when they are on and off. Switch on and off is shown with the closing and the opening of the wire. A switch on is shown with the wire connected, and off is when you show it open so that current is not able to flow. Similarly, a battery in a circuit could have more than one cell. Here in this diagram, the battery has 2 cells, and in the next one, it has 4 cells. And the symbol used for multiple batteries has been shown here. The positive and negative terminals are shown in series. Notice here that the negative terminal of one cell is connected to the positive terminal of the other cell. So friends, you can try creating a circuit on your own with a source of battery, a bulb, and a switch. It may be interesting to see hands-on how circuits work, or do the exercise in class with your friends. Moving on, let's discuss some effects of this moving current. The moving current, as we see in the circuits, lights the bulb. The wire gets reasonably hot when current passes through the circuit. Such phenomena is referred to as heating effect of a current. You can easily think of appliances that heat up due to heating effects of current. Microwave machines, electric room heaters are all examples. Connected wires become red hot and radiate heat, and excessive heating may lead to melting of wires. You must have seen toasters burning or fuses being blown due to excessive heating of wires. Wires have an element, and the amount of heat generated depends on the length, thickness, and material of the wires. Nichrome wires produce a lot of heat when electricity passes through them. Friends, fuses have a very important role to play in circuits. Imagine if there was excessive flow of current through a circuit and no stopping mechanism to prevent overheating in a system. Such circumstances would lead to massive fires in houses and complexes using all kinds of electrical appliances. So to prevent such disasters, fuses are used. Fuses are made of special wires that melt quickly when large current flows through them. These are inserted in all electrical fuses within a given safety limit. If current exceeds that safety limit, the fuse melts due to overheating and stops the flow of the current. This prevents the outbreak of a fire. Now you may ask, what are some of the causes of excessive current? Sometimes, my friend, there are too many appliances connected to a wire. This causes overloading and hence overheating. Sometimes wires become old and there is wear and tear, and insulation is not adequate. This may lead to short circuits. Current has other properties as well. Just as the heating effect, electric current can also generate properties of a magnet in a wire when current flows through it. Whenever a coil behaves like a magnet with flow of electric current, it is called electromagnet. In this circuit, you see that a wire is coiled around a nail and is connected to the circuit. You will be surprised to know the moment current flows through the circuit, a magnetic field develops. If you hold a few iron fillings in front of the coil, you will notice that the iron fillings cling to the coil because of its magnetic property. Remember, the properties of magnet ceases to exist when the current stops flowing through the wire. This property of electromagnets was developed by Hans Christian Ørsted. Electromagnetism is widely used in electric bells. Notice that there is a coil that is connected to a battery source and an iron strip. When the current flows through the coil, magnetic properties develop that pulls the iron strip inwards. With the pulling of the strip, the gong of the bell gets pulled to strike the bell. This then makes the bell sound. So my friends, now you have a fair idea of how electromagnetism works, how heating effect is created due to current, and so on. We hope you've enjoyed the lesson and look forward to seeing you again. Goodbye.